We're going to pick this video up where the last one left off. This is the center main journal bearing. And the only thing left to do on this guy here is to round off either side so that it matches the bottom half at assembly. Going to rough most of the material off so that I don't have a lot of surface contact with the boring bar for the reverse boring operation. Tool mounted backwards in the holder. I'm running the machine in reverse right now. And I'm back boring the journal. I'm only going to go to the parting line so that it matches the other half, which is still a raw casting. And of course, the first side takes longer than the second side, which is why that went so well. 2 cuts. It was actually quite a bit more on the first side. Laying the fixture down, I'm going to use the same centerline philosophy to drill the holes so that they match the base. And I will ultimately shift the clamp and put a small tapped hole in the center for an oil cup. I will show you that momentarily. With the top half of the center journal bearing completed, I'm going to move on to the end bearings, doing them exactly the same way that the center was done. 2 holes, 1 threaded hole in the center for an oil cup, and we're done. Let's take a quick look at the bearings before we move on to the next part. I drilled and tapped oil cup holes in these, and they're on the same location as the hold down bolts. And that's about 2.5 thousandths off center because of the way I moved the holes in the frame. Not sure if I'm going to stick with this particular profile or not, or go with a hex and relieve that. I don't know. I'll know when I get there, though. So those are the 2 ends, and the one in the middle also has the tapped hole. But luckily, I had these oil cups in reserve from the lathe or the mill or shaper, one of the other models that I built. Too bad I didn't have 3, right? All right, anyway, that's the bearings. That's what they look like. Finished up. This guy came out nice. I'm very pleased with the way that looks. Still got some cast residue on the one side. All I did was hit that with gently with a file, and then hit it with Scotch-Brite as well to take some of the matte out of it. All right, let's move on to the next piece. Next parts in line are the standards. These are the risers that come up from the base and guide the crosshead that drives the connecting rod. I guess the first part of this is going to be break out the file and have at it. There's some flash on the inside, but I have a feeling that a lot of that flash is going to come out of there when the bore operation is done, so I'm not going to kill myself to clean that up. I will take the file and grinders and such to this. Now, one thing that's important about these guys is that the center line of the base is in line with the center line of the top. You don't want them doing this at assembly, and you certainly don't want them doing this at assembly, because then the pipes won't fit. They would probably still function if the bore is in line with the base, perpendicular to the base, but that's yet to be seen. And I tell you, I recently had an interaction with the Stuart Model Company customer service, and 2 thumbs up, guys. Very impressed with how well they handled specific questions. Relatively simple part. A couple of holes on the top, through bore, 4 holes on the bottom, parallel surfaces perpendicular to each other, and an established diameter on the top. Back over here is where they go. We're doing these pieces right here. So first thing to do, break out the files, settle in. It's going to be a long one. Not really. These pieces are in pretty good shape. But take off the flash lines to your suit, to your liking, and make it look like they were never there. That's the plan. Let's do it. It's amazing that when you sand these things, how heavy they get. So if you see me just putting it down every once in a while, well, that's because they're heavy. No, they're not. They're incredibly hot when you sand this stuff off. Ouch. All right, let me clean off the top, and then I think we'll do some bench work. Maybe when they cool down. Maybe not. For now, I think that'll be sufficient. That'll give me something to clamp down to if I need to. I will ultimately rub these across the piece of emery on the band saw table just to see that there was no influence when I was pushing this up against the belt. All right, let's go over to the bench. Removing the flash lines from a casting is a part of these projects that I really do enjoy. When you're done, or when I'm done with a component, I like to look at it and I like it to look like there was never a flash line there. So if you hand it to somebody or somebody observes it, they just expect it to look that way because that's the way it should look. I'm going to use a half a dozen different files to achieve this. A couple of coarse rounds, a couple of fine rounds, a teardrop shape file, and a few flat, fine, and coarse as well. I'm not going to take one piece and finish the piece, start to finish. Once my hand gets comfortable and I have the file selected that I like to use, I like to do all the features of all the parts and then move on to the next one. I'm very cautious about how much I take off. I'm going to blast it and then inspect it, and if I like it, then we'll just move on. But for the most part, I want it to make like the flash line was never there. That's the goal. Take your time. You're going to look at it for a lot of years, so take your time. Some of the flash lines on the inside of this part were a little bit aggressive, and a good technique for knocking down a heavy-duty flash line, use a round file. Instead of a lot of surface contact with a flat file, use a round file and put a series of little ridges in it, and then knock all the ridges down with a flat file. And on this particular model, whether or not the surface is presented at assembly or not, I'm going to make sure that it's nice and smooth to the touch and to the eye. Well, I think for the most part, you get the idea of how much work it actually takes to do this. This is compressed footage, of course, but you're looking at about a half an hour worth of nonstop filing. And the reason I'm bouncing back and forth in between parts is because when you find a nesting position that you like, stick with it. You know, do both parts and come back and then find another position for something else you like, the right combination of files, and have at it. I'm going to work on this guy right down here, and I'll tell you, it's ringing the file as I go across it, so that's probably a little bit harder than I'm comfortable with. Let's see if I can sneak that into a grinder or a mill setup and knock that down before I finish filing it out. But after I blast these, I'll come back and I'll show you what it's all about, and then I'll discuss the logic behind getting these things in line so that everything lines up as intended. Well, literally after a couple of hours of filing and about 5 minutes worth of blasting and touch-up, this is what we got. Both pieces are very clean to my satisfaction. Now, naturally, you can file off all the casting marks if you want, but then it kind of loses some of its character. So if there's a rough edge or two, I decide to leave it there because I think it's going to look good when it's assembled. The OD on these things does need to be turned down to match the base of the cylinder. And everything has to be in line this way and this way. So the next step in this process is to measure these things. Let's find out what I have and exactly where everything is, because you can't trust just because you indicate that the hole pattern is going to be true to the bottom, or because you set up off of this, that their holes are going to come out in the center of this. So it's really important to take your time on this next step and know what you're working with and know where the material's coming from. And if you got to tweak a couple things, well, so be it. Ideally, I would like to press it against a vise this way and true up these surfaces based on this diameter. That way I know pushing here, of course, cutting here. So I'll know that the bottom is true this way. And then it's a matter of probably flipping it up against a 1, 2, 3 block on that surface, banking on the diameter, and establishing this and this. Not to any specific diameter, just clean it up so that you know that it's true. Well, sounds like a plan. I'm go inside the inspection area, pop these on the surface plate, and if there's anything wonderful to see, I'll show you. I'll be right back. In order to get some feel for exactly how this is sitting, I need to know whether or not the top is true to the sides. And you can see if the top is not true to the side, well, the distance from the outside surface to the head itself is going to vary side to side. This is the setup I came up with. About plus 2.5 on this side. Flip it over. Minus 2.5 on that side, so that's about 5 total out. Not bad. Closer than I thought it would be. Second piece. Plus 2. Plus 5. 3/1000 of an inch. Not bad. That's less than 0.1 millimeters. Next step is to move these, cut these parallel. Just so I know what I have to work with. I'm going to take the smallest one, which is 845. And I'm going to make all the other ones 845. There'll be some back and forth. Once it's squeezed in the vise and I know that it's true, well, I'll indicate the vise and then I'll indicate the top and bump the part back and forth until the top is concentric. At that point, I'll take a dust cut, flip it, take another dust cut, and start all over again. So it's going to be back and forth a couple times before this piece is true, but when that happens, when you do it right, the crosshead slide should be right in dead center of the casting. Everything should work out fine in the end. Let me set it up, true these up, we'll check it again. There's a 3/1000 of an inch difference between the thickness of this foot and this foot here. If I were to just register against a parallel, I would take 3 off of this side, but it would cock the part. So I want to split the difference and take an even amount off of this side and the underside to bring it down to this thickness. So initially I just want to just barely touch this surface, take about 1.5 thou off of that, remove the shim, flip the part, lather, rinse, and repeat. Here we go. Now, if all went well, I'm 1/1000 from being parallel. When I remove this, this will drop down. The table will come up 1/1000, and the majority of the cut should come off of this side, which will actually be over here, the next operation. Being held in place by a half a ball. Chuck Bomarito over at Outside Screwball used to sell stuff like this called Screwy Balls. So if you haven't checked out Chuck's channel, go check him out, and he may still have some of those left. This is actually a used or scrapped femoral head from a hip implant. So try to get your hands on one of those. Good luck. Now that I can trust the alignment is true to the sides tilted this way, it is time to align it this way. Thought process. I know how wide the base is. I want the base true to the top. I'm going to indicate the jaws. See the indicator 0 in the back. And let's see. Although the arm blocks it out, we're about a half before on the front and about a half away in the back. Now, without moving the table, I'm going to bring the indicator up and I'm going to check 4 locations on here after the earthquake. Left and right, I want that to be true, and I will adjust that with the table. Front to rear, I am not going to move the y-axis. I'm going to actually tap the part. That is going to bring the top diameter true to the feet. I'm going to deck it off. Once it's decked off, it's going to be flip-flop, flip-flop. It's going to be 1-2, 1-2 machining like you've seen me do in the past. So once this is parallel, once this is flat, I will then bank on this and cut the bottoms of the feet again to make the whole stack parallel. All right, let's get to it. And yeah, I hate using an indicator on a casting, but this is more for reference than for concentricity. Got a 0 on the table, got a 0 on the digital. Now let's do the casting. And I did check the top diameter prior to this operation to make sure that it was relatively round, and it's within a couple thousandths. I always start sweeping a part with the indicator off the part. You can see how far away that is right there. And when it comes around to the opposite side, 180 degrees out, I look for a similar gap. And I'll just adjust the whole piece until that gap looks fairly uniform, and then I'll bring the tip in contact with the part. That'll keep you from jamming your indicator and potentially damaging it. A little closer, do it again. Got a little contact in the back with the needle movement, and nothing in the front. So left to right, I will line up by bringing the indicator around the front of the part so I don't bind it. Needle's about +2 right now, dropping away. -6, that's 8. So -2 should be the money right there. -2. Let's see what we got. We got a -9 and coming around big time. Voila. Zero in the front. +5 +7 in the back. plus 2 in the front. Plus 3 in the back. Very close. Half in the front, 2.5 in the rear. Minus 3. Minus 3. That's money. Now at this point I can be sure that this diameter is true to the base, that the center line is the same, and regardless of how parallel or not this top surface is, it's about to become flat. So when I flip this thing over, I will then be able to take the error out of the feet from this tapping operation. Then I'll trust that everything is true and straight to each other. Then it's just a matter of bringing in heights and boring it out. That's the plan. I am not going for any dimensional configurations at this point. I am not going for anything that's on the print. I am strictly looking for flat surfaces. That's all I'm doing. Here we go. Now, for everybody that's going to ask me why I didn't use a bigger cutter, well, it's because I don't have a whole lot of grip on this part, and the part is not being squashed in here. It's being held gently, and I didn't want the cutter to tear the part out of the vise. So, for anybody curious, that's why. It's about another millimeter or so to come off the top, but I think I may do that on the lathe when I do the boring operation. That way I can assure that my bore is true to my face. Let's clean this up a little bit and take a look before we flip it over. Now this, I'm really glad that this has happened. There are the perimeter of this particular unit here. Let's see if I can catch that just right. There you go. Can you see the dark halo on this one right here? And this one doesn't have it. In my limited experience with castings, that would indicate that this one cooled a lot faster than this one did. And the outside, since it's so thin, naturally cooled faster than the stuff with a little bit more mass. And that is indicative of a hard spot. Very uniform hard spot, I might say. Didn't really notice it while I was cutting, but when I ran it across the emery, it shined it up real nice like that. I was like, holy mackerel, there it is. So I can expect to see a difference in the facing operation on this as well when I put it in the lathe. There is a difference in the thickness here, but you can see the step down in the parting line. So unless I want to cock this thing and straighten that out, in which case I'll lose my center line, I'm just going to have to live with that. And you know what, if I didn't point it out, you probably wouldn't see it anyway. This one is a little bit, but not too bad. Alright, this is a reference surface. We're going to strap them down like this now. We're going to dust the bottoms off, and then we're going to have true geometry on the outside and parallel faces. I may put them back in now that there are parallel faces to clamp on, dust them again so that not only are they true, but they're square because they're going to be out. Ever so slightly, it'll be tense, but it will be a little bit out. And I want it to be the same in case I put these in any type of a nesting fixture for the boring op, which I'm going to do on the fixture in the lathe. I wanted to make sure I can use the same fixture for both parts. All right. This is next. Simply a cleaning op coming up. this one's done. This one is not done. And what you'll see is the deviation of the part being tapped in the vise. It's about 2.5 thousandths out of parallel. But that's exactly what I thought I'd see. There you go. Let's take a look at the fixture that I'm going to be doing the rest of the work on. This is the nest for these guys. Clamped on either end. And set up in a 4-jaw chuck. I'm sure I could have probably figured this out on a faceplate, but with the top being true geometrically to the base, I'm looking forward to seeing how this thing actually runs with all the theory that I put into it. I will chuck up on a 250 gauge pin, a reamed hole in the center for future operations if I want to do anything else. I know right where the center of that pocket is easily. And after I finish boring these out and facing them off, I will cut a recess in this pocket that matches the diameter so I can then reclamp it and do the holes in the feet based on the center this side. So let me hang this pin in a tailstock drill chuck. Set this up in a 4-jaw. And you may have to come back for this one. I am running out of time. But let's get this thing set up, and I will promise you I will lead off the next video with the boring and facing and drilling of these towers. Standards. Thank you for watching. I do appreciate you spending some time with me. Wherever you are in the world, I hope you're well and happy and safe. All of the above. I'm Joe Pye here at Advanced Innovations in Austin, Texas. I'm out. I am very pleased with the concentricity of the ID, and since the remainder of this part is going to be finished when the face and the bore are done, I'm going to leave it as is. It's about 5/10 out of perpendicular, about 1,000th out of concentricity, and that's all for today, guys. Thanks for watching.